Oh, well, hello there. So today, we're going to go over one final problem with continuity. And this is sort of the quintessential end of the topic problem that you have to do. And it'll also introduce you to the kind of problem you have to do when you learn differentiability in a few weeks. But here is continuity. We're given two functions, a quadratic function and a linear function. And you know that both of those are continuous everywhere. So really, the only point we're going to be concerned with is x equals 3. And what's going on here? We'll take a look at it graphically, and then we'll solve it algebraically. Let's take a look at the graphical analysis first. Here's what we have. We've got x squared minus 1. X squared minus 1 is our opening up parabola, vertex 0, 1. You've known that since you were a knuckle dragger in Algebra 2. We plug in 3. We know this wants to get up here to 3, 8. But we've got an open circle there because less than. And we know that we're on that parabola when x is less than 3. So let's see. Here's 0, 1. So I've got a parabola coming up here and then up like that. Now, here's what we have. We have the line 2ax. Now, I don't know what that means. It could be 2x. It could be 2 times 3x. It could be 2 times a half x. I know that it's going to go through here at the origin, but it could come up like, could come out of here. It could come out here. It could come out there. It could come up here. Either way, we've got to find one of these lines that goes through this point, right? And I'll do that in red. That's the line I'm looking for. How do I figure out what that is? I figure out what A is. And really, that's what we've got here. So let's do that. We know that the point has to be 3, 8, right? And so for continuity, that means the limit as x approaches 3 of f of x from both sides needs to be 8. And I know that f of 3 needs to be 8. And if that's true, then our function is continuous. So what's left over? I know the limit as x approaches 3 from the left is 8. I know f of 3 is 8. The limit as x approaches 3 from the right is 2a times 3. So what I'm saying is that 2a times 3 has got to be 8. So therefore, a has got to be 4/3. We'll see in a moment if that makes sense. So what we're saying here is that if this is y equals 8/3 x, then that should work. Let's see. We can screen share to our calculator, or we can just try it on a grapher. But either way, that's right. When a is 4/3, that becomes 2 times 4/3 x, 8/3 x, 8/3 times 3. That's right, it's 8. And so as this line comes out here, we're at y equals 2 times 4/3 x. And this line over here, or this curve over here, is y equals x squared minus 1. Does the limit exist from the left? Yes. Does the limit exist from the right? Yes. Are they equal? Yes. Does the function value exist? Yes. Does it equal everything? Yes. Wow. A whole lot of yeses right there. Our function is continuous. Next, we're going to take a look at what this all means.